right. Here we go. Okay, look up. Okay, everybody focus. Okay, homework tonight is the pink packet. Something I noticed, I don't think any of you did this, but I've seen other people do it. Look at me. Don't do your work across the page generally. Once in a while I will do a short thing from like across, but usually that will cause more mistakes. Your brain can track a lot better going straight down the page, I guarantee you. That's why I lay out the work in columns versus wide, because you do better going straight down. So I'll do the same thing on Tuesday. I'll walk the room, ask if you have completed the packet, and have 0 questions. I'll pay you extra credit again. I'll also check the notation again on Tuesday, just to make sure we're getting on track on notation. I won't do the notation check always, just kind of here and there. It's also important that you remember the big idea here. All we're ever talking about so far is really just an x versus a y. And when we do a limit, they're telling us the x, and they're also telling us how to compute the y value right here. They give us a formula. So it's critical that you remember that when we're finding a limit, it's just comparing an x to a y. That's all we're doing. All the steps we do in between are just to allow us to find that y value. It turns out they give us some formulas sometimes that if we didn't do some sort of manipulation, it would become very difficult to identify the y coordinate. Last night's homework, every single problem said analyze the continuity. And I had you practicing to do the left limit, the right limit, the value of the function, the overall limit. This handout is a little bit different. It doesn't say anything about continuity. The instructions at the top say, for every problem, find the specified limit, and then identify whether or not there is a horizontal asymptote. So every problem on this pink has 2 parts. And if you look at the answers in the back, you'll notice that the answers are also broken into 2 sections. There is the part where we are finding the limit. So here's the answer to number 1, as far as finding the specified limit. And then there's a section over here that talks about whether or not the function had a horizontal asymptote. So for everything on pink, you'll do 2 things. For class today, we're just going to go through problems from the homework, discuss together, make sure that you feel like you're on track to do the rest at home. So, okay. Start with number 2. I sent out a text yesterday saying that I posted on Canvas 9 different videos from the packet. In case you find that that would be helpful, you can refer to those videos. I'm going to make more videos today in class. So right now we're recording another one, so if you would like to say anything clever, feel free. So go down in history as on the video. The funny thing happened one time. I have a habit when I want you to kind of just come focus for the discussion, I'll like just come clap, or sometimes I whistle like that. And one time I was making a video, and I was telling the class to come back and focus for the discussion. I whistled. Later I had a student tell me she was at home studying the video, and I whistled and her dog came running. Clever. All right, here we go. Number 2 says to find the limit. This is new. I would make a flashcard for this right here. This is what I will refer to all year long as the limit flashcard. Have to be honest, if we were doing more complicated limits, this might not always work. But I've never seen this fail for an AP question. Like, this is really good for everything that they're going to give you. So whenever I'm asked to find a limit, the first thing I always do is what you see in blue. I check to see if the limit has the input variable approaching infinity. And if yes, I'm going to compare terms. Terms are by definition things that add together, but just for emphasis, I say that we want to compare terms that add. So here's a little note about terms versus factors. There's a sign on the wall by Amanda Lindstrom as well. So, questions? I'm just going to pause for a second while you get that written down. Okay, what I mean by compare terms that add is the following. In this formula, the numerator consists of two terms that are added together. The first term is the 2x cubed. That is being added to a negative 16x squared. Okay, the entire pink packet consists of nothing but power functions. The packet you get next time that's yellow, that will include log and exponential functions, and the rules are different. But for today, the rules are pretty simple. When we're comparing power functions, it is the highest power function that grows most rapidly. And as x is allowed to grow forever, this higher power function will grow so much faster than the other that it's almost like you don't even notice you're adding the other. I did something in Excel to kind of demonstrate that. So let's show the Excel results. Back here. All right, so this shows, I used n instead of x, but it's the same idea. So this shows n getting bigger and bigger and bigger and bigger. So here's n at 1 billion. This shows what happens if you take 3n cubed. This is just negative 5n. Questions so far? And then I combine them. I say let's take a 3n cubed and add it to a negative 5n. And initially when n isn't really too large, we definitely have some sort of effect due to the negative 5n. But you should see that that negative 5n's effect is really not very significant. In fact, once you get to here, Excel just refuses to even pay attention to it. It's like it's not there. So even the computer won't really count that contribution as being very significant eventually. And that's only with n reaching 1 billion. We're allowing n to grow to infinity. So it just completely overwhelms. The same thing happens if you're going to negative infinity. The 3n cubed becomes negative instead of positive, but it's extremely negative. And that other term that we're adding really has no significant effect. So, questions on any of this? Solid. So back to the problem. So when I'm comparing terms that add, basically I say, okay, I really only need to worry about the 2x cubed. Do not make the mistake of ever comparing terms that multiply. The logic is not valid. It's only valid for when things are added. So I'm going to write on my paper, you should do the same. Write an equal sign. You have to write equal. If you leave off the equal, the grader takes away points because it's impossible for the grader to follow your work if you're not showing him what's equal to what. So equal, make sure you write limit. I saw some people forgetting to write limit. That will cause a loss of points. Now we create an equivalent limit problem that is a lot simpler to look at. On the bottom, when we compare, we find that the negative 4x squared is dominant. Questions about anything? Please, Blake.
So when you write that out, you just choose the ones that are a higher power.
When you're comparing power functions that are adding, and x is approaching infinity, we only need to pay attention to the highest power function. 2 more points. Just make sure you only use this method if x is approaching infinity or negative infinity. Okay, next step. It says we should factor and divide. So I'm just going to write this in a slightly different fashion. So I say limit equal x approaching infinity. And let's see, let's take out the 2 here, -4. That's going to multiply by an x squared divided by x squared. We're still going to have an x over 1. Does anyone have trouble recognizing that this blue box is exactly the same thing as this green box? Questions about that? They're the same thing, I've just written it out in a way that makes it easier to talk about. Cool. You need to memorize a key fact. The key fact is this. Whenever you have something divided by itself, that doesn't cancel. I prefer that you not use that word. What this does, this divides to become 1. So you need to memorize that something divided by itself is equal to 1 unless you have 0 divided by 0, which is undefined. Questions? So for our class, usually it's better not to cross this off because it tends to lead to errors. So, questions? Sweet. For example, let's check the whole room, we'll pay extra credit. For this formula right here, well, we can't do that. Never mind, let's move on. So now all we have to do is say that this limit, we're just again comparing an x coordinate to a y coordinate. Here's our x. This is how we're going to compute the y value. So we use the formula to compute the y value. And we end up noticing that we would have -1/2 multiplied by 1 multiplied by x over 1. But x is going to keep growing forever. That means this will grow forever. So this whole thing will just become increasingly negative. So what we really want to write, we don't want to put an equal sign there. Let's do this. This is really just me thinking about it. So I really should put that over here. The result is this is headed towards negative infinity, or a limit that is non-existent. Questions about you? Please, Katie.
That last step feels really tedious. So for like 2 over -4 x squared over x squared, like can you just eliminate that if you already see it from top?
2 points. Let me say back what I think you're asking. Is that okay? If you can look at the green and mentally process the blue and come up with the result, you're fine. Is that what you meant? Yeah. There's no need to actually write out the blue. I'll do it in class quite a bit because I've just found that about half kind of just can't quite see the jump sometimes. Does that make sense? Good work. That's pretty consistent, Kaylee, on the AP test. Like, I'm big on making sure you have the right notation, but you'll find that you can skip quite a few steps if you can do it in your head. They're not super picky on that. Once in a while, there'll be something that I'll just remind you that, oh yeah, that one they're going to want. So, okay. Keep asking them. Anybody else? Solid. Okay, we've done the first part of the problem. We found the limit they asked us to find. We still need to identify whether or not the function has horizontal asymptotes or not. So let's do that. Move this away. Pull this out of the way. You need this flashcard as well, right there. When they ask you to find a horizontal asymptote, they are asking you to find the limit as x approaches positive and negative infinity. That's what they are asking you to do. So we've already done half the problem because we've already found the limit as x approaches infinity. All that remains is to find the limit as x approaches negative infinity. Okay, now, like, look at me. Do not miss this little warning. So everybody look up. Jake, look up for just a second. Don't miss this one. When you're dealing with strictly power functions, I showed you that spreadsheet that showed that as x approaches positive infinity or negative infinity, the dominant term is the same. So for power functions, the analysis for positive infinity really is the same for negative infinity. We'd end up in exactly the same place. When we plug in a negative infinity, we will get a slight change in the sense that, okay, so let's write it down. So we could go right to the blue, because if this were approaching negative infinity, we would still get the blue result. So over here we could say the limit, there's no equal sign here because we're doing a new problem, of negative infinity. We have the 2 over negative 4, x squared over x squared. None of this would be any different if x is approaching negative infinity. The final result will be slightly different. Raise your hand if you know what goes inside the orange box for the value of the limit as x approaches negative infinity. Just checking the whole room to see if you can mentally process it. Just raise your hand when you know what belongs in this box of orange. So apparently my explanation wasn't quite as good as I was hoping. So everyone give yourself, well, those who raise their hand, give yourself a point. To find the horizontal asymptote, we have to find the limit as x approaches a positive infinity, which we have done. We must also find the limit as x approaches a negative infinity, which we are now doing. So these are two separate thoughts. This was x approaching positive infinity. Now I'm doing x approaching negative infinity. But I didn't have to start back over at the very beginning. Whoops. That is not what I wanted. I didn't have to start back over here at the beginning because when I'm comparing terms that are adding, if x is approaching negative infinity, I'm going to end up in the same place. So I just started right there and said I need to find this limit here. So just think back how we found this result, and I was hoping you'll be able to do this limit as well. So let's try again. Who knows what goes in the orange box? Still same people. My extra hints did not really help very much. Lucas, what do you got?
What else is your negative infinity?
2 points. Let's try it. So this will be negative 1/2. This will equal 1. This will become increasingly negative. So the negative multiplied by the negative will actually give us a positive. So as x becomes extremely negative, the y-coordinate becomes extremely positive.
Oh, it's because
That makes sense.
because the x is approaching negative infinity, so the x is negative. Oh, I see.
Do you see it? 2 points for asking.
Can we write that down on our paper?
So this is part of what, this is all part of problem 2.
Oh, so the negative.
We have to do the part where we find the limit that they ask us to find. And now we've got to do the analysis to be able to talk about the horizontal asymptote.
That would make it way easier.
Does that make sense, Kaylee?
Yeah, I was just saying it would be easier if you could write in the negative sign with the x on the top equation, so you can just mentally process it.
Yeah, and you can do that if it helps. Like you can just kind of come over here to the, like the grader won't care if you just off to the side a little bit, do a little thinking. So you say, okay, I've got negative 1/2, and I have multiplied by 1, and then it really doesn't make sense to multiply by negative infinity, but it's like, oh, I've got, negative something, and just pretend thousands big. And so you see that these will multiply, of course, to give a positive, and hence we know that. So, nope, 2 for Kaylee. What else? Come back. Last thing to do here is we must talk about the horizontal asymptote. That was part of the problem. So now we can write on our paper the following. As x approaches a positive infinity, we have y approaching negative infinity. That is not a horizontal asymptote. That means if you were drawing a graph, as the x-coordinate became extremely positive, the y-coordinate's going to, other way, become extremely negative. So the graph would have some sort of downward trending appearance. Don't know exactly what, but it would be going down to the right. Questions about anything? If you want to talk more about it, please.
Just, is there, like, can you pick a point on that bottom one to determine, like, the reverse thing?
Pick a point on the
So where
bottom.
you picked negative 1,000 for that,
Uh-huh.
could you just think about it and realize that it's going down and to the right? Will it always go up and to the left, or will that mislead?
That would be misleading. It all depends on what the formula is. So I'm literally just, again, it goes back to the big idea, 2 points for HT. I have a formula for finding y coordinates, right here. Because I'm only concerned about y coordinates when x is very large, I have an easier formula here. It's just quicker for me to process. And so literally I do what you did. I say, negative 1/2 times 1 is just negative 1/2. That's just going to get multiplied by some large x. So yeah, when x is very large and positive, x is way over here, y is very large and negative. Did that help? Yeah. Okay. Please.
Would this graph look like one of those
Uh,
curves?
Being completely honest, Aspen, I don't really know what kind of curvature the graph will have as it goes to the right. I only know that it's going to go down.
Yeah, but and then on the other side it goes to the left.
Oh yes, that's very
so
good.
it would be like kind of like an X.
Maybe. It actually could do things I don't really... Graphing isn't a big part of AP Calculus, so my graphing skills are weak. So when I look at this, I can't tell you exactly what it's going to look like. All I know is that over here, the points are climbing. Over here, the points are going down. So there's no horizontal asymptote. We can finish this. 2 for Aspen. And now we've finished problem number 2. Want to talk anything more about that? Please, Blake.
But if you completely switch it.
So the fact that as x gets very large, y gets very negative and large? Is that what you mean?
then just not
Right, so that's what we, 2 for Blake. So this was our analysis to figure out that when the x value is becoming very positive, the y value is becoming very negative. This was our analysis to find out that when the x value is very negative, the y value is actually very positive. This is simply a summary of our work. 2 more, please ask.
What would you do if you had 3 terms in a function, like on number 1?
Look at the big one.
So if you have 3 terms,
Do you just do the biggest power still?
yeah, the analysis doesn't change. You could have 12 terms, it would still be the same.
Okay.
As they add together, like on the spreadsheet I showed you, it only showed 2 things adding, but it really doesn't matter. If you add multiple terms, and they're all, you can be careful with the rules here. Multiple terms and they're all power functions, the highest power function will dominate.
Okay.
2 more. So really on number 1, it starts out looking like it would be perhaps more difficult because there are more terms displayed. But my very first step is going to be to create an equivalent limit problem that is significantly simpler. So let's do the whole room. Aspen gets 2 for asking. Raise your hand, please, if you can tell me what new formula am I going to put inside of this brown box based on my use of this blue principle. So you're comparing terms that add to transform this complicated formula into a simple formula inside the box. So what more simple formula goes inside the box, Kennedy?
Negative x squared over x squared.
Negative x squared. Because negative x squared is the dominant term of the 3 in the numerator. And then what's on the bottom, Kennedy?
X squared.
Okay, 2 for Kennedy. Show me your hand if you were prepared to say that point. Okay. Questions? Aspen, did that answer your question?
Yeah.
Perfect.